Assalamualaikum and good morning. I am Amirul Shah. My group members are Fledzil, Nurfatin Lalila, Shafiq Khalid, Darshan Sharma, and Siddiq Ilmawan. We are from Group A6. We'll present about electrically conductive adhesive using copper filler reinforced epoxy composite.
And I will talk about background study. Conductive adhesives are prepared by loading organic resins with small particles of inorganic fillers that are generally metals, metal oxides, and metal nitrides. Although all metals have a good electrical conductivity and can be used to make conductive adhesives, most of them are easily formed and insulating outside layer through air oxidation. There are a few advantages of thermoplastic polyurethane, or as we know as CPU. CPU fossils are essential polymeric materials. It exhibits high strength and considerably greater abrasion resistance. Next, it has much shorter processing cycle time. In general, a TPU is a block copolymer consisting of hard and soft segments that play an important role determining the properties of the material. It also can be processed either to ready molded parts or can be incorporated by multi-component molding. In both cases, it shows decent mechanical property. In present work, the relationship between melt process in GPU morphology and resultant thermal mechanical properties were examined and determined by means of quasi-static tensile test, creep experiment, tension test, and dynamical mechanical analysis, or DME. Scanning electron beam microscope, or SEM, and differential scanning calorimeter, or DSC, were used to study the morphology of the samples. So there are a few problem statements in this report. Conventional method of soldering, which is using lead in electronic industry, has been a major problem for everyone. It has disadvantages such as produce dust and fumes that are hazardous to health, which contains poisons. It can build up in the body due to many small exposures over many years. Besides that, there are a few problems of conventional adhesive in electronic industry, such as it has low impact strength, low reliability, and low conductivity due to reduction in bond strength generally occurs on aging at elevated temperatures and under moist conditions. They also have limited stability to heat due to the fact that adhesives are organic compounds and have lower thermal conductivity compared to solder interconnects. The major problems for this conventional adhesive was that most adhesives are not electrically conductive and must be converted by adding a filler to the base material. Therefore, this problem in conventional method contributes to the research of newly formulated conductive adhesive material, that is using copper and PU as the raw material to substitute the dead solder.
For nanocomposite, thermoplastic polyurethane is a type of multi-block copolymer synthesized from a dissociate and a long change diol with a small molecule diol as a change extender. TPU elastomer basically a sub-segment with a glass transition temperature which lower than room temperature. TPU elastomer have been extensively used over the field of coating, footwear, automotive, and biomedical industry. The electrically conductive TPU composite have arisen comprehensive interest in electrical areas like antistatic, electromagnetic shielding, and sensing material. Porous structure such as foam, sponge, and aerogel which feature lightweight, large specific surface area, and high porosity. Porous materials have been widely spread over biomedical scaffold, catalyst carrier membrane filter, thermal insulators, superchemical absorbent, and energy absorbers.
Hi, now I will tell you about the materials development. The study also stated that the carbon nanotubes is promising as is a pronounced deepening effect for the layered silicate. The nanofillers can pronounce the strength effects, but as far the highest tensile strength can reach up to 45 MPa, the nanofillers is considered well in industry. So next is to develop the the, the material. So first is solvent casting. In the solvent casting is in a organic solvent the polymer is solubilized. Then the nanoclay is dispersed in the resulting solution, also aided by strong shear. Ultrasonic energy homogenization of the solvent is then allowed to evaporate, usually as a thin film, leaving the nanocomposite behind. In order to intercalate between the silicate layers, the solvent imparts the increased mobility that the polymer requires, whereas the more dynamic flexibility coupled with physical mixing gives rise to a disperse method. Next is melting processing. The processing of melt refers to the single or twin screw extrusion process, whereby polymer chains are melted to increase their mobility, and then the nanoclays are distributed into the melt to allow the nanoclays to be intercalated. Much higher shear energy is necessary for twin screw extruders or bra bender mixers, so caution is required when processing thermally responsive TPU materials, as vigorous melt processing eventually results in a loss of molecular weight and a decrease in properties and efficiency. Next is in situ polymerization. This method involves with the dispersion of clay layers into matrix by using polymerization. This step includes the mixing the silicate layers with the monomer in conjunction with catalyzed or polymerization initiator. Lastly is reactive extrusion. For reactive extrusion on fabricating TPU composite, it involves with in situ polymerization of TPU procedures such as polyol, desikcinate, and the change extender in a twin screw extruder. Nanofillers may be either fed sideways as dry powders or predisposed into pressure polyol liquid which use chemical modification of existing polymers. The extruder in this method used as continuous chemical reactor for polymerization which helps in fabrication of TPU.
Then we go through the characterization of copper and TPU. This is the Curie method. So the copper powder and the TPU were mixed with the self-assembled monolayer and have the oxidation through actin treatment. The mixing materials were stored in the freezer for several days before use. As shown in the figure, the sample was left on the hot plate which has the temperature of 150 degrees Celsius for 60 minutes. Immediately remove the sample from the hot plate once the completion time and let it cool at the room temperature but still under argon atmosphere. The first test is the resistivity test. The copper thread was tested by a Catley 580 micrometer to measure its resistivity. For its theoretical formulation, the resistivity also obtained from the equation, which is resistivity equal to the width times with the thickness of the sample over with its length and times with the resistance. The resistance was measured using the 4-point probe method. Meanwhile, for the tensile test, a stretching force was applied to determine the elongation ratio of adhesive. And the elongation ratio is the lambda equal to its length over the initial length. And for the engineering strain equal to lambda minus 1. Next, for the functional of electrical flows in the circuit, the sample was fabricated and connected with the standard surface mount technology, or also known as SMT components, which are the components consist the chip, resistor, capacitor, transistor, and LED.
Next is project summary. This project summary is about selection or substitute material for the development of new conductive adhesive. It is highly functional and reliable at varying temperature and humidity. This report is about why the selection material is suitable as following requirement. The material is PMMA filled with copper. In the field of coatings, footwear, automotive, and biomedical industries, TPU elastomer have mechanical robustness, high resilience, small compression sets, and excellent resistance to impact, abrasions, tears, and weather. Copper metal is a soft, modifiable, and ductile material that has different application as a conductive filler in electric industries because it has high electrical and thermal conductivity and good cost-effective electromigration characteristics. Copper tends to oxidize rapidly under moderate conditions of heat and humidity, which can be controlled by many methods, including organic or inorganic copper coating, nitrogen-based copper treatment, and the addition of solvent powder to the adhesive system, etc. Copper surface modification involves plating with other conductive metals such as silver, which provides some improvement in stability. That's all for me, thank you.
As conclusion, we can conclude that recent advances and applications of conductive adhesives bring many advantages to electronic industry in terms of materials, processing, and reliability concerns. Conductive adhesives have overcome many challenges to meet the higher electrical, mechanical, thermal performance, fine pitch capability, low temperature processing, and strong reliability requirements, and get improved to be relevant in electronics manufacturing field. Next, a new material systems for conductive fillers and adhesive materials are developed for ever increasing demands in electronic industry. A good example of conductive fillers and adhesive matrix like TPU and copper can be used for electronic industry. Thank you.